Here I have my Lambda function that updates my Notion database with YouTube stats every hour. And here we first go to configuration and general configuration. Click edit, and the first thing we need to change is the timeout. By default, it is usually set to 30 seconds. So if you expect your function to take much longer, for example, minute and a half, then you need to set it to probably minute and 45 seconds, possibly 2 minutes, depending on how long you expect it to finish in the worst case. Here, we actually don't need it to be running for 5 minutes. So we're gonna change it to, let's say, 1 minute and 15 seconds. And the reason we want to do that is because AWS bills you by the number of invocations, which means the number of times your Lambda function runs, as well as the execution duration, meaning for how long it runs, and how much memory it uses. So the first setting we've changed is the timeout. The next setting we're gonna change is memory. There are a couple of reasons we may wanna do that. If your code is CPU or memory intensive, then memory is the setting you need to change, because as you can see here, with increasing your memory, your CPU proportionally increases as well. And when you increase the memory, your duration time can actually go down, meaning that potentially your AWS bill will decrease. When AWS decides how much to charge you for each AWS Lambda invocation, it uses your memory setting as well as your invocation duration and creates what's called a gigabyte second. So here, if we change it, for example, to 512, just to make it a little easier to count, our memory is now in the formula is going to be 0.5 gigabytes, because we need to create gigabyte seconds, not megabyte seconds. And then, for example, if our function ran for 10 seconds, then it's going to be 0.5 times 10, which will be 5 gigabyte seconds. It's what you will get billed for. So for example, if you had your memory set at 128 megabytes and it ran for 15 minutes, potentially if you increase the memory and your invocation time goes down to maybe 3 minutes or even 5 minutes, you may be getting savings on this invocation duration time, because your gigabyte second will be lower than it was before. These two settings you definitely want to change when creating your function, just to make sure you don't get overbilled, and also to make sure that you are getting a good performance out of your Lambda functions. The next setting you may want to change is concurrency. And there are two types of concurrency that you can change. The first one is called reserved concurrency, and the other one is provisioned concurrency. Concurrency applies per region, and by default you get 1000 concurrent executions for all of your functions within that region. And concurrent meaning executing at the same time. For example, when you have multiple Lambda functions and all of them are competing for resources, and one of them gets executed much more frequently and takes a lot of this concurrency away from your region, then you may want to provision reserved concurrency to your other functions, just to make sure they have some amount always available. And if you don't set this up, then all of your functions will compete for resources, but AWS will automatically scale it based on demand. So if you don't have too many of these AWS Lambda functions, that you probably don't need to worry about this setting. The other type of concurrency you may want to configure is called provisioned concurrency. And the reason you may want to do that is when you use, for example, your AWS Lambda functions with HTTP triggers, for example, when a customer clicks a button on the website, then it executes this function. And by default, Lambdas have this downside of cold starts. So provisioned concurrency keeps these instances warm and always ready to respond. The only caveat is that you will have to pay a little extra to have that done for you. And as you can see here, looks like we still get first million requests per month for free, as well as 400,000 gigabyte seconds. And then our limits are a little higher per 1 million requests a month. So let's just put, for example, 2 here and click save. And it says that alias is required. So we could go and create an alias, but the problem is that alias cannot point to the $ latest version of the Lambda. So first we need to go to versions and publish new version. So we just click publish, and now it will actually let us provision concurrency. So we just click edit and put, for example, 2 in here, click save, and that's it. Eventually your status will go from in progress to complete or success, but that's how you provision concurrency to make sure that your AWS Lambda instances are warm, or at least a couple of them are warm. How do you determine which values to apply to all of this configuration? If your Lambda has been running for a while, what you can do is look at your metrics. Here we click on monitor, And then you can click view CloudWatch logs, or we could just, type CloudWatch in here and right here and just go to CloudWatch. But what we're after is metrics. Here on the left, we click metrics and then Lambda, and then we just choose by function name. If you have more than one function, then just filter by the function name you're interested in. And the first thing we're interested in is the duration. So here we can just set it for a week, and we can see that the maximum it has taken was about 36,000 milliseconds or 36 seconds. So we could actually go and update our configuration to set it to maybe 45, 50 seconds, probably no more than a minute. Then for the memory, it does get a little tricky. AWS has this GitHub repo called AWS Lambda Power Tuning, and I'm not gonna go deep into it in this video, but basically it will test your function with different memory settings and tell you which one you should probably use. I'll put the link to this GitHub repo in the description, so feel free to experiment with that. And the last thing we're interested in is how much concurrency we need to provision. Well, there is a metric for that as well. It's called concurrent execution. So we click on that, and as you can see, my function never has more than one concurrent execution. And this is it. These are the 3 settings you probably want to configure when you create your Lambda function, or potentially change if it has been running for a while. And if you want to know how to create this Lambda function that updates your Notion database every hour, querying the YouTube API, Notion API, how to use CDK, put it all in Docker, and just have it automated with just 3 commands that you need to run, then watch this video that I created previously.